presenting. Can you see the screen? It might be a bit compressed because it's high resolution, but
seems okay to me.
Yeah, good. So let's mash these two subjects up then a bit. The vision of the product as it evolves, and what MDrivenServer does and when it does it, because they are sort of intertwined in one way. As you said, Damien was part of Borland and made this eco product, and part of a release cycle aiming primarily for developers. We got some audience then, but the challenge was always that it was too many moving parts in the product as it looked then. You could use it in so many different ways that everyone that used it found their own way of using it, and it was hard to sort of bring things together to make some progress from it, because as soon as everyone used it in multiple different ways, it was really hard to know which way to choose going forward. Just to mention a few of the ways that it could be used was that you could have a built-in persistence mapper that the FAT client immediately talked to the SQL server, and that was sort of the way you did things in the 90s and early 20s to get things going. But pretty soon that was a security threat, and we wanted to move everything to a persistence mapper that was its separate process. And as we did that, it became really hard for people to follow that, because how would you communicate with that persistence mapper that you were supposed to build yourself, and where should it run, in what server environment should it execute, and how should we communicate with it? So initially it was with the RPC, remote procedure calling from built-in in .NET, and that became a security threat, and it was sort of discontinued, and Microsoft introduced Windows Communication Foundation. And Windows Communication Foundation was sort of good because everyone could configure it any way they wanted, and inject different kind of security protocols, etc. But then that was really hard, and most people leaned to HTTPS as the security protocol to get crypto on the wire. And it was really cumbersome to get it working, and it was sort of unique roles within the projects that was only geared towards getting communication working between client and server. And of course it was fun for them, but it wasn't fun for anyone else, so things never working. And we had a lot of people having problems building their own persistence mapper server, and so the vision then became that, why is this so hard? This should be easy. Let's build a generic persistence mapper server that sort of always work and always is there for you, and you don't have to tweak it anything. Yeah, great, you can do that, but if you're gonna do that, you need to submit the whole model to this persistence server, because the way that we did it before was that you included the model project into your own built persistence server. So we did some research on how to get a persistence server totally generic, and we named that boring predictable server, just because it was not supposed to do anything. It was just gonna work. It was supposed to be boring and predictable. And we set that up with VCF, with a standard VCF connection. Then sort of nowadays Microsoft have deprecated VCF as well, and they're running everything over web API, and so do we. So we still have support for VCF, but no one uses that. Everyone uses web API instead to talk to the boring predictable server that we aptly renamed to MDrivenServer, because it was pretty cool. So and one of the things that we did with the what we ended up doing with the generic persistence mapper that turned out really good was that one could just get it going with something like this to run it locally as well, to have it as a development environment, and all of a sudden you were able to do a complete local development environment with servers and client and everything in one on one desktop. And that would be exactly the same once you put the server on Azure or anything else. And there was really very little to need to attend to when deploying your application. So as these servers are running now, I can just say that I'm going to use those about servers that I started. I'm going to check server starts on those. Okay, it was never started, so no current version. Then I can just upload the model and see that it recreated the database for me. And I can update the server-side jobs. There are no server-side jobs. Good. So the MDriven server will sit here, and these local turnkeys will always default to user A and password 1, 2, 3, 4, 5, 6, and that's because they are meant to be local. This is just like on the good old Borland Delphi days, when the password for interbase always was master key, and everyone knew that it was that, so it was never a problem to get access. So having done that, we have a complete persistence mapper in the cloud that talks web API and has a database. And that means that as I add things to my model, and head back to upload the new model, there's a whole lot of things that goes on and are maintained for me without needing to recompile my server end, and everything is boring and predictable. And so that was pretty neat, but people tended to use their server side to more than just persistence mapping. They wanted to be able to run logic there as well. So could we find a generic way to run logic? And that was a really good, it turned out really good that we made use of the OCL even for executing server-side stuff. And one of the main things was the server-side view models, and that was more or less something like this that you do as server-side view model, and this we will run on server for a specific class, and then you could simply put actions here that did something. So the server, once it will execute this view model, it will just act as a user and push the buttons from top to bottom. And since we have a thing object, we have some properties on that. We can do some int here, and we add 1 to that. So how can we make it execute on the server then? We need to enable criteria for server-side execute. And then we simply can say that the server should check for thing all. Let me do this here. Let me remove these breakpoints. Let me get back on the screen, something like that. So all instances. Select all x where some int is smaller than 100. And it should check this every 5 seconds. And I upload the model again and update the server-side jobs. And now it says that, whoa, there's a server-side job. That's named like this. And what we will see then on the MDriven server is that we have something we call periodic actions. Okay, so this one will run every 5 seconds, and will be a dot when it runs. So we will see that it has executed, and I can see any log that it has done, and I can force it to run. And now we're getting into the territory of your question, Henrik. When does it run? So suppose that we have lots of server-side jobs. They will show up like this one, and typically there will be, well, there's nothing typically about it, but maybe you have 20, and they all have different intervals, and the intervals will show up as different density of points in this overview. And what the server does, that it checks for if the ones that hasn't been executed within their current interval, and orders them on some kind of priority, and that priority is more or less just how long was it since they ran last time. And who is it that does that then? Well, it's these jobs, the server internals, periodic actions supervisor. So that this one is just making sure that everything is working. And this one, watch A0, that will make sure, that will check if there's a new model, and if so, it will run the evolve loop to bring up the server up to speed. This one, periodic action check, it runs typically every 3 seconds to check are there any more stuff that are in queue. Suppose that it finds a queue of 20 things. Then it will not do 20 things, because that would make the server go become too busy. It will only do 4 things in parallel. So 4 things in parallel, and it will never do the same job, the same name of the job in parallel. It will always serialize jobs with the same name. And why is that? Well, often a job might, if it sort of assigns a number or something, then you don't want it to run into itself to get the same number twice. So it's really important to be able to trust that it will serialize jobs, job instances of the same name. What we will see here is that this job, if I press update, it runs, and that would mean that if I connect this, if I start this system with let's see, it would be good if I could see the sum int that is supposed to count up here. So I'm gonna go into this view and just add column sum int here. Let's make that read write as well. Heading back here and refreshing the model. I'm gonna remove these breakpoints, or so. And here we can see that these numbers are increasing, and it looks like they are all increasing all at once. So we're gonna create a few more. These won't be increasing because I haven't saved them yet, so the server can't see them. They are only in memory. Once I save them, the server will be able to see them. And they are still sort of increasing all at the same time. So what I wanted to see is if there will be batches of them, because that's what I suspect, that if we have enough, they will start to be handled in batches. Let's see how we define the job. So it will run every 5 seconds, and max answers is -1, and -1 signals that it's unlimited. But maybe, so what this means, that when this query is executed every 5 seconds, it will return all the objects. It won't be limited, and then it will execute each one of instantiate. For each this object, it will instantiate such a view model and press the buttons and save. So if we have 1,000, it will try to do 1,000. So that's might not be perfect. Let's turn this down to 5. And now I have to instruct the server that this is the new deal. So I'm going to upload the model again and update the server-side jobs. Actually, in this case, it would have sufficed with pressing the update server-side jobs, because that made this value yeah, maybe you can't see it here, it's really poorly designed. Anyway, we will go here, and so now these are 36. Now these are 36. So these, yeah, so now we don't have any, since our criteria says that take the first 5, they will always be these. So our criteria should probably order them on some int, so that the lowest one will be executed first, in order, because these will be left to their destiny until these reach 100. Once they reach 100, they are not valid for the criteria anymore, and then these will be handled. But if I add an expression here, order by some int, then I think the lowest will come first, and it will be a better fit for what we want to do. So I'm going to upload server-side job settings, and what we can do also in this UI, periodic actions, and there's a link here, criterias. Here we can actually see and test out what objects this will find. So whenever I press this expression is executed, and it will find these currently. But this is really good for debugging as well, because here I can temporarily change things that I don't want. I only want those that are smaller than 10. Okay, there are no smaller than 10. Smaller than 50, or maybe even bigger than 30. Okay, there are some. Let's see if there is some bigger than. And what I also can do straight from this UI is go into one of these objects, and this is really good for debugging. I can do execute on that and see what will happen if when that is actually executed, and I get the log from that. So this might be a silly example, because I only press this button that's called action column, and that touches one object. But suppose that this is a REST service that does something that goes out to another server and do things. Then it's really practical that I can just stay here and press execute again to debug and see the log for what's happening. So this is good functionality that hasn't been displayed enough. Heading back to the application, we can see that these are now sort of evening out, since it's taking the 5 smallest first. These are 23. Now these will get updated to 23, I guess, like that. So there are different aspects of picking jobs, and I guess that is what is a bit confusing, because this single job picks objects to work on, objects that fits with the criteria. And if we have multiple jobs like this, we have an orchestration between those jobs. So 4 differently named jobs at a time. And I say this with a good confidence, but there's an exception, and that's the sysasync ticket, which is handled a bit differently. So the sysasync ticket is a model pattern to make it even easier to get things running on the server. So let's see what the sysasync ticket is. To get that going, we need to sort of merge in this, because I don't think we have it. We can see if we have something that's named sysasync. No, we don't. No problem. Then we just go to the wiki and search for sysasync package, and here's a lot of text on what it does, but that's not really needed. We can just download the modeler package, and now that's in my download folder, and I can go here and merge from my downloads the sysasync merge model, and that added this diagram with a sysasync ticket and a the sys superclass I had from before, so it just added this diagram and some of the associations. So I can save this now, and I can then upload this new model and update the server-side jobs. And I can see that there are new tables added to the database, and probably there will be new things added to the MDriven server, because the MDriven server has been knows about the sysasync ticket pattern. And what it does when it discovers that your model follows the sysasync ticket pattern is that it adds these 2 server-side jobs. And these 2 server-side jobs work pretty much exactly the same as this, but it has well, we can look at it, I guess. It has been automatically created for us, but it looks like, no, that was the wrong one. Looks like this: sysasync ticket, all instances, and it checks if the ticket is already done or if it has a default value in done. It checks that it has a root ID, so it knows what object to actually work on. It checks that it execute earliest isn't set, or that it's smaller than now, so in the past. And this is something that will be used internally to avoid, because now we have this issue with, as I said before, we must trust that a job that has the same name is never run in parallel, because that will confuse number assignment, etc. It will confuse a lot of things. Think of if you have something that goes out and asks a REST interface, and you all of a sudden do it twice and fill in the result to some singleton, and you will be confused as to what happened. Which one did they run in order, or did they run in parallel? But the sysasync ticket wouldn't be any good if it would do all jobs or if it wouldn't do any jobs in parallel. So what it does is that it checks the name of the job. So if the name of the view model or the method that it will execute, if it's the same name, those names won't go in parallel. But besides that, it will try to, this too will try to do 4 jobs in parallel. So 4 threads on the server can be assigned to do things in parallel. Suppose that you have 1 or 2 things that are really heavy and slow. That will bind up one of the threads, and that will show up in the work info as long red lines, because this dot is time relative. So if it's something that runs really long, it will be a long red line here. So what we can do now is let's go and take a UI to easily submit a sysasync ticket. So from this view all things that I had, I can do a let's do a class action on thing. This will do things on server, not here. And the execute expression could be self do things on server. So there will be a method add. We're not allowed to add method that way, so I'm going to do it this way. So do things on server, and it's not a query, and the body should be self. And since I'm a inherit from syssuper, I got these new methods injected with the sysasync package called do async. Yeah, probably what I want to do is that, yes, we're gonna wait with this, and instead we're gonna call this in the action that we did. This will do things on the server. Execute expression. And let's see this one. If I send in a string called thing to denote which class it's gonna find, and Yeah, now I don't remember what it was called. Sub-expression, self, methods, do things on the server. So I can instruct the pattern to sort of send an async ticket, because if I look at this, it doesn't do anything complex. It just create one of these sysasync tickets and set the root object. Like that. So the action will do this, and let's see, I'm gonna go and fix this method, because what is that gonna do? This method is gonna do self some string and append server. And let's, yeah. So what will happen when we instruct the server that there's a new model? It wasn't any schema changes. And we instruct the prototyper that there's a new model. And if I'm on one of these this will do things on the server. This will then create one of these async tickets. It won't happen anything yet because it isn't saved. It's just in local memory. But once I save it, the sysasync ticket job on the server will discover that there's something that should be done. Let's see how it's doing. So I don't see any errors anyway. So if one ever is in doubt when it will run or not, go to criterias and yeah, you can't run it because of this, so you could edit that locally and see there's no sysasync tickets that are supposed to run, which is strange. We did one. So let's see. Then I can go to data in my system to do the auto forms. Let's do that in a separate tab. Check sysasync ticket, search, and see. Okay, here I see that the sysasync ticket is there, but it reported an error on it. It couldn't find thing.thing.do things on server. Okay, so the method that I'm using is already adding the class name, so that's okay that it got confused, because I was confused myself. So I'm gonna remove that then. And having done that, I can then restart the prototyper and take one of these. This will do things on the server, and save that. This will do things on the server and save that. Now I should have two more. I do. And these hasn't been executed yet. So let's see. Well, now they were executed. So that's a really practical way to sort of do things that you of course could do in the UI, but it might be time consuming. Perhaps you're asking for a authentication thing from an authentication cookie from Spotify, and that takes 2 seconds on a good day and 10 seconds on a bad day. So you don't want to sit around and wait for it. You just want to spin that off and have it done for you, and then it would be a really good thing to have the server side or the method to do that server side, and give you the cookie in a persistent attribute that you then can use to query more stuff. And Emily, you had an example where you did this, where you were deleting a lot of things, and the user probably didn't want to wait for it to happen, just want to point out, delete this, delete this, delete this. And instead of having the user to sit and wait for spinning cursor to, because deletion is always cumbersome when there's a lot of associations, because in order to delete it we need to bring everything in and untie it from everything else, and possibly there's cascading deletes in the model that we need to delete thing by thing by thing. So in our case, even if the user only wanted to delete 10 things, it might be 20,000 objects that's being thrown away. So then it's much better to be close to the database, which we are on the server, not necessarily super close on the client, and we can gain speed that way also. Questions, Henrik? Anything?
Quite good. So if we have a couple of hundreds of existing tickets, they will run in one thread, because they're all the same.
They're all the same, but there's an option to set the priority attribute on them.
Yeah.
And you can do that manually, and the priority attribute will be honored, and a small value is better. As you can see, if you...
But they will still be in the same thread, right?
There are 4 threads for doing it, but if they are the tickets that has the same name of what they will execute will be after each other. Yes.
Okay. So even though, yeah, the priority is not part of the name then?
No.
No. Okay. Yeah, I understand. Okay. Good.
And also, if no priority is set, it will take the one that was created the earliest. So you don't have to wait super long. You don't end up, you end up in a line, and when it's your turn, it's your turn. No one gets ahead of you unless they have a higher priority.
Okay.
So,
Good.
and I think this is back to your question, Damian. This is very much part of the long-term plan for the product, because when we took these steps in introducing the MDriven server and packaging everything, we removed a lot of degrees of freedom for the developer. But we, as we feel it, we made it a lot simpler, a lot fewer choices, and fewer things that can go wrong. And all the degrees of freedom that we removed, we think were buggy and not good architectural patterns. So we try
Yeah,
to
I agree with that approach. Yeah.
yeah. And pretty much what we have been doing since 2010 is reducing ways you can use the product to sort of streamline it into having a set agenda that this is what you're gonna do. You're gonna build information systems. They're gonna be database and client server based, and you're gonna have a clear vision of what the logic does, and that logic must adhere to things that you have in your model. If you can't express it in the model, it's something else and it's not part of the system. And of course that doesn't really limit us in any way. We just have reduced the what do you call it when it's the infinity of all possibilities. Now it's just a smaller infinity. It's still an infinity what you can do, and all the good things are there, and an infinity of bad things are not there. So the goal of the product is to streamline it to be even more like I like to look at it as when in the 80s, when the handheld calculators came, it was a revolution for everyone that was doing anything with numbers. And this is the same thing. It's just a calculator, but for information and not only numbers. So this is a revolution for everyone that's doing anything with information, because now you don't have to have a lot of long-term memory or working memory of yourself. You can use the machine to get things going and to build really complex thoughts that are type safe and don't have any side effects that you can't easily see. So the goal and the main idea for the product is to be the calculator of the 2000s, the calculator that uses information instead of numbers. And OCL is the perfect example of a algebraic approach to thinking, but for information instead of just for math. So, and I think this is something that's gonna dawn on people a little by little, but I'm pretty sure that this is the way humanity is destined to walk to get higher efficiency in information handling.
Yeah. Hypothetically, I suppose we could have databases talking OCL instead of SQL. I mean, if they were object-oriented under the hood and all of that.
Yeah, so it's interesting that SQL is really good and it's nothing wrong with it, but the degrees of freedom that it gives you are a bit too many, because of course you can join first name with the sys table name, but that's nonsense. It's like just because something is possible doesn't make it a good thing. And if it isn't a good thing from the start, I'm not saying that you never want to find someone that has the same first name as a table in a database. That could be a valid case. But if it was a valid case, then you would have built a model that represents that. You wouldn't just discover functionality that you can connect things that you haven't expressly said that these are connectable. So it's sort of reducing the degrees of freedom so that you don't hurt yourself. And I think we really need that, because as complexity grows, which it grows really quickly, as soon as you add 100 classes with 50 associations, you're way beyond what you're able to easily have in working memory at any given time. But still, most software systems today don't have a clear representation of what they have. And that's really fantastic that we're still in such a caveman-esque environment. And everyone tries to look at the other guy to say that, do you remember how this was? Nope. Let's check the code.
Because programming is still an art, not an engineering discipline.
Yeah, and I believe that making solutions are art, but how you apply the color to the canvas, that's engineering. So we should not say that this isn't truly fantastic creation, that when we make models to solve real business problems, it's not just engineering, it's discovery, and it's fantastic when you find good solutions. So I think it's art. Like a good bridge, it's art when it looks good and it's really practical, but you might call it engineering if it's just a generic bridge that there's this is just 1,000 incarnation of the same drawing.
Well,
I read somewhere that a modern model isn't necessarily better than a historical model, but it's probably better because you probably have a better understanding of the world.
Yeah.
That was Hans that wrote that.
All right, good. And is it Don Box that said that all models are wrong, but they can still be useful? And that's also an acceptance of that reality is complex and evolving, but you still need to make sense of it, even if it's evolving. You can't just abdicate and say that, well, I'm gonna write a program that I don't even remember what it said on the first line, because now I'm on line 100,000 and there's no way I can have that in working memory. That's crappy, and that's how we get planes crashing and Toyotas running into walls and things like that, because no one really understands what's within it. Okay, good. Sort of used up the time here, but I think we got a good overview of the server-side jobs, and also tie that into the basic idea of why we are doing this and why we are doing the MDriven server, and what the goal and aim is to reduce complexity and get things working without too much technical crap.
Great.
Yeah, and if it can make it less likely we shoot ourselves in the foot, it's a good thing.
Yeah. Okay, good. Thank you for tonight, and hopefully we'll see you in 2 weeks.
Yep.
With something new.
Thank you, Hans.
Thank you.
Thank you.
Thank you.
Thank you. Bye.
Bye.